Alright, let's look at some basic logarithmic properties, and these are hard to see exactly the location, so I tried to rewrite them here. This one's the first one, second one, third one, fourth one. In particular, this is log base b of b to the x power. The rest of them you can see. So first of all, we can see how this is true because this would be b raised to the 0 power is equal to 1, right? And that makes sense. B raised to the first power is equal to b. B to the x is equal to b to the x. And then same thing here. But we can now use these as somewhat shortcuts when we're asked to evaluate not using a calculator. So let's look at 13. 6, this is going to be anything log of 1 power is just going to be 0, right? Because it's like asking ourselves 6 to the what power gives us 1. Alright, when this matches this, our answer is just going to be 15. Okay, because that matches our, it's just, this may be hard to see this one there. Let me make that a little more clear. That's like big B, like b raised to, this is all an exponent. This part right here is all an exponent. So like this. 6 raised to the log base 6 of 15. When this matches this, you get 15. Alright, now this one, when this matches this, the answer is whatever the exponent is right here. What is the exponent in this particular case? 1. Good, which that matches this particular property. Okay, and this last one, when this matches this, the answer is 18. Which one of these does that match? 1, 2, 3, or 4? 3, good. So we can see when the b matches the b here, the answer is just x. So when 7 matches that 7, the answer is just 18. Good. So this is just using the properties to be able to solve. So if you're just familiar with these, it's kind of like shortcut steps. The next thing is common logarithm functions. Basically, anytime you have a logarithm, it's written with the base 10, and I'm going to rewrite this. So it's log base 10 of x. If you just see log of x, then we know it's an assumed base 10. Just like when you have x, it's assumed to be known as 1x, as well as it could be the same thing as 1 as x to the known 1. So there's a lot of known things. When we see x, we know the coefficient's 1. We also know the exponent's 1, but we don't have to write this every single time when we see x. Well, when it has common logarithms, if it's just log of, if you're given log of 3, then we know it's an assumed base 10. They don't always have a 10 there because it's assumed, just like we don't always have the 1x to the first power, we'll just have x. So, and the same thing for natural log. So for this particular one, when you see natural log, it's really natural log of e to the x, but we don't always have to write the e because it's known to be there. So this is usually commonly seen, as well as this, but when we see those values, we need to know that this top one has a known base 10, and this has a known base e. Okay, so we'll keep those in mind when we see log of 1000. We may not see the 10 there, but we know it's there. So it's like 10 to the what power equals this. Okay, so we want to know 10 to the what power is equal to 1000. So what's that give us? 10 to the third power, so the answer is 3. There's a known base 10 here. When I put that there, it makes it easy to see my property, because when this matches this, what do we have? The answer is just 7. Okay. A natural log of e. What's the known base of a natural log of e? Known base e. And then if I put my known base in there, then it's clear to see that e is equal to 9 using our properties. Number 10. Okay, and we continue. There's a known base e here. So when this e matches this e, the answer is the exponent. What's the exponent this time? Just a known one. Good. And then here, e to the anything, the natural log of a 1 is just going to be what? 0, because we're saying e to the what power equals 1. So the answer is just 0 in this particular case. So basically what we did in 17 through 21 is we practiced with the common logarithms because the known base wasn't shown. Although we know it's there, it wasn't shown. And then we used our properties to evaluate the expressions because it told us not to use a calculator. Alright, that pretty much wraps up the lesson, but I'm going to do a few extra examples just to give you some practice of some of the things we covered, and I'm just going to write these in. These are not included in the printout of the notes, and you can add these extra if you'd like. Okay, if you were given this one and you want to write it in exponential form, then we would get 2 to the 4 equals x, which in this actual case we can say 16 is equal to x, but this is the form. Okay, if they ask us to evaluate, we would keep going until we found out what x is. But part 2 says write in logarithmic, so we want to convert from exponential to logarithmic. And check yourself, you should get log base b of 16 is equal to 4. Or if you had it in the other format, it could be. These two are equivalent, so either one of these are correct. Okay, now let's evaluate. We have properties now, so we can check to see if it matches a property. We can use a property, and if not, we ask ourselves 3 to the what power equals 81. So this would be like 3 to the what power equals 81. And we would say that box needs to be what? 4. Good. 36 to the what power is equal to 6. Yes, so 1/2. Now this one we actually could manipulate this a bit so that it does match a property. How could I rewrite 36 if I wanted it to match this base? I mean this argument. How could I rewrite 36? 6 squared, right? So as a side note, I could use this to rewrite as log base. Instead of 36, I can say 6 squared equals a 6. Actually, this one won't match, will it? No, because it would have to be this equal to this, so it doesn't. In this particular case, we will do some manipulations of these in a later lesson. I was just going to try to show you an example before, and it didn't work out. So, but this particular one, we can use a property, right? 5 raised to the what power equals 1, or we can just use our property that tells us that's going to equal 0. Yeah, so this one's just 0. Try to get a little bit ahead, and that didn't work out on that one. So let's see some more examples. Okay, if you want to write these down and then try them, then you can come back and check your answer. Okay, so when this matches this, we get 15. 2 matches 2, we get 3. 9 matches 9, we get 1, the known exponent 1. This one didn't initially, but I can rewrite 1/3. It's 3 to the negative 1 power, and then now these match and we get negative 1. Probably could have used this idea on that last one that I was trying to work with, but we're going to wait till the later lesson. And this is kind of the idea.